All right, picking up where we left off in the 1.6 notes, we went through and talked about all the formulas for the perimeter and area for all these types of polygons. So now we're just going to do some examples together using those formulas. So please make sure you have those filled out correctly in your notes. Okay, so the directions say to find the perimeter and the area of each figure. So if I'm looking at the first one here, this rectangle, I know that I need my length and my width in order to find the perimeter and the area for that matter. So perimeter general rule, add up around the sides. Or for rectangles, you can double the length, which in this case is 4.6 centimeters, double the width, 2.3 centimeters, and we get a total of 13.8. Make sure you label units, centimeters for that perimeter. For area of a rectangle, we simply do length times width, which we talked about the other day. So my length is 4.6 in this case, times my width, 2.3. I get an answer of 10.58. Okay, now the units on this, think about it. We just did centimeters times centimeters versus with perimeter, we were just adding up centimeters. So our final answer was in centimeters. But when I times centimeters and think of your units for area, we'd have centimeters squared. Awesome. Okay, let's go to this next polygon. This one is 7 sides. This is a heptagon. That's good review over your vocab. Now this is a regular polygon, meaning all of these sides are congruent. They're also showing me that apothem, which that was kind of one of our new vocab words for the other day. It's a perpendicular segment from the center to the side of a polygon. They're showing you that marking right here. So that's my little apothem. Okay. That's the information given to me. So to find my perimeter, remember, I'm going to just flip back to our chart here for a regular polygon. We can just do the number of sides, and right here, times the side length. So since there's 7 sides here, do 7 times 13.9, and we get 97.3. When there's no units of measure, we label this units. Area for a regular polygon, I'm just going to rewrite this on 1/2 times the apothem times the perimeter, and I'm getting that from the chart that we talked about yesterday. So 1/2 times the apothem, which is 14.4. Struggling with my marker there. 14.4 times the perimeter, which we just found to be 97.3. That's what a capital P stands for in that formula. All right, for that number, just crunch that number in your calculator, folks. 700.56 units squared, since we're talking about area. All right, just a lot of practice with plugging some numbers into our formula and doing some simple multiplication and addition. Talking about perimeter. We're doing a lot of addition here. Okay, moving on to this triangle. So I know for the perimeter of a triangle, there's no really handy-dandy formula because, as we can tell, all 3 of these side lengths are different. So I just have to add up all the sides. So I know I have this 3.9 meters plus 1.2. And then I'm like, ooh, I don't know what this side is. It's across from my 90-degree angle. We call that the hypotenuse. But we know we can use the Pythagorean theorem to find that side length because I know my 2 legs, 1.2 and 3.9. So I can square those, add them together. That'd be my hypotenuse squared. Okay, I'm just going to do some quick math here. I get 16.65. Square root both sides, we get 4.1 for that side length. And remember, our hypotenuse should be the longest side in our triangle, so that makes sense. All right, so add that in to my perimeter. You can label it on your picture if you want to. That side's 4.1. Add those all together, get 9.2 meters for that perimeter. For area of a triangle, I do 1/2 base times height. So in this case, 1/2. My base is 1.2. My height should be perpendicular to my base, is 3.9. So for this area, I got a final answer of 2.34 meters squared. Okay, we're gonna do one more triangle. This one's just a little bit different. But I know for perimeter, I still want to add up all the sides. So this side length is marked as 15 inches. This side length is 7 inches. And this side length is 13 inches. So we get a total of 35 inches for that perimeter. Okay, now you might be wondering, what is this 11 inches marked over here that's perpendicular to the base? That's giving you the height of the triangle, right? Because if you look at all of the sides of your triangle, none of those were perpendicular to your base there. So none of those are true heights of that triangle. So when I go to find the area and I do 1/2 my base times my height, my base and my height have to be perpendicular. Okay, so my base is still this 7 length. And now my height, I can check over here, is 11, which I'm sure you've maybe seen something like that before. 38.5 inches squared is what we get for that area. Okay, so just a lot of practice of applying some of the formulas that we already discussed in class. Let's look at a couple circle examples. So this first one says find the circumference and the area of the circle. And I'm kind of looking at what's labeled for me, and they're giving me this distance, with that, which that is our radius of our circle. Our radius is 8 meters. So there's two ways we can find circumference. One of them is 2 pi r, and the other one is pi d. Now, since I'm given my r, since I'm given my radius, I'm going to use 2 pi r because I know my radius is 8. Okay, now in your calculator, you do have a button that will calculate pi. So you can hit that button, 2 times pi times 8. Or what you can do is use the number 3.14 for pi. So you could also do 2 times 3.14 times 8. Okay. But on your calculator, if you can't find the pi button, I can help you do so. If you have one of those basic ones, it's usually like on the left-hand side, kind of like right above that up caret arrow. You could also use that button. If you're not comfortable with that, just use 3.14. Or like I said, if you want me to help you locate it on your specific calculator, don't be afraid to ask. When I got that answer, I got a value of 50.24 meters. If we're talking about circumference, which remember, folks, we talked about this, that's the distance around the outside of the circle, about 50.24 meters. Okay, area of a circle is pi r squared. Talked about that yesterday as well. So what's nice is we know our radius is 8 meters. So now again, you can either use the pi button or use 3.14 times 8 squared, which is 64. You should get an answer of, and I'm rounding these two, folks, 200.96. Now, we know normally with area we have some type of unit squared. So right here you squared your meters. So that's where that meters squared would come from for the units on your area. Okay. Next one here. Suppose the right triangle above, I think they're talking about this one. Yeah. This one from the last example. I'll flip back to it quick. This right triangle they're talking about. Suppose the right triangle above was wrapped around with a rope around the outside. Here's my red marker here. Suppose we took a rope and wrapped it around the outside. What would that distance be? Well, that would be that perimeter, that 9.2 that we found. Okay? So then this question says, so we know that perimeter was 9.2 meters. So then they're asking us, what is the maximum radius of a circle which could be made with this same piece of rope? So if I wanted to go around the outside of a circle with that rope, that would be my circumference, which is 2 pi times my radius. So what is my radius? We're going to have to solve for r. That'd be the same length as this rope, which we said was 9.2 from the perimeter of that triangle. So we're going to have to do a little math here, a little solving. Okay, so you can do 2 times 3.14, or you can use that pi button in your calculator. But I'm going to divide by that number. It's about like 6.28. You could call it that as well. Or like I said, use the pi button. I like to use the pi button because it's more exact. But we have to divide, or you could divide it by 2 first, then divide both sides by pi. But we should get about 146. And this is a radius. This would be meters. Would be the maximum radius of a circle that would use exactly all 9.2 meters of that rope. Anything smaller, any radius that'd be smaller, obviously the circumference would be smaller and it would use less rope. All right, that's a fun question. Okay, a couple more. I threw this one in because last time we had a problem like this on a coordinate plane, a lot of you struggled with it, with finding perimeter. And I said, hey guys, you know how to find perimeter? Just plot the points, add up all the sides. You're also practicing like distance formula a little bit. So let's go ahead and try this example. It says find the perimeter and the area of this pentagon. So A is 0, 4. So I'll mark that A. B is 4, 0. And C is 3, negative 4. D is negative 3, negative 4. And E is negative 3, 1. Okay, so take a straight edge. Connect all those vertices. There's your polygon. It is a pentagon. It has 5 sides. Okay, so to find the perimeter, I'll do that in green here. I need to add up all these sides. Some of these sides I know. Like if I look at this segment, the side DC, and I can just count squares there, that's a length of 6. Same with DE or ED. I can count up, and that's 5. However, the ones I'm dashing here from E to A, from A to B, and from B to C, I'm going to have to use my distance formula. Okay, you could also draw little triangles and do Pythagorean theorem. That was another way we kind of learned how to find distance. But I think this is good review of our distance formula. Okay, so I'm going to start with line segment AB. So this one right here, I'll highlight it in green here. This is the one I'm finding. So for a distance, we got to do the square root of the difference of the x-coordinates. So I'll call this x1 and x2. So x2 minus x1 squared. Add that to the difference of your y-coordinates. So you gotta stay consistent. So if you call the first one x1, that's y1. Point B, we call that y2. So then I'd have to do 0 minus 4 squared. Okay, I'm gonna do this quickly because we've done this before. So I get 16 plus 16 there. I get the square root of 32, which is about 5.7. Now we're gonna have to do the same for BC. Let's do that one. Okay, BC. Difference of my x-coordinates. So this time, doesn't really matter what way you do it. Let's call this x1 and y1, x2 and y2. So 3 minus 4, square that, plus the difference of your y-coordinates, 0 minus negative 4 squared. Oh, I did that backwards here. It should be negative 4. Doesn't really matter because we're squaring it. Negative 4 minus 0 squared. There we go. Okay, so inside there I get 1 plus 16, square root of 17, which is about 4.1. All right, one more we need to do that. This one right here, AE. So this distance is the square root. So A and E. I'll call A x1, y1, E x2, y2. -3 minus 0 squared plus 1 minus 4 squared. Good review of our distance formula we talked about earlier in chapter 1. Either way, I get this 3 squared plus 2 squared, so 9 plus 9 squared root of 18, which is about 4.2. All right, so to find the perimeter, we just have to add all those up. So let's start, and you can label it if you want to. This is 4.2, 5.7, 4.1. All right, so let's add all those up. And I got 25 units for the perimeter. Okay. Now the area is kind of interesting because we have a bunch of different shapes we kind of have to add up here. So I'm going to section off this as a square and 2 triangles. So I'm going to shade the top triangle in red, the side triangle in blue, and then I will do the square in black here. Okay, so we're going to do the area of the square plus the area of the triangle plus the area of the other triangle. Okay, let's start with the square. Or I shouldn't call this a square. It's really a rectangle, right? Those aren't the same. It just kind of looks like a square. A rectangle. Base times height. Base is 6. Height is 5. That's why it's not a square, because those are not the same. They're close, but they're not the same. So 6 times 5 for that piece. Plus, okay, let's look at the triangle. 1/2 base times height. Okay, that base, if you count your squares there, looks like it is 6. Same length as your rectangle there. And then the height, we can count the height because it's perpendicular to our base. I counted 3 boxes there for our height. Okay, now we have this little blue triangle. 1/2 base times height. So that base right here is 5. It's the same as kind of the width of that rectangle times the height right there. The height is just 1 little unit. Okay, that's a lot of number crunching. So we get 30, let's see, plus 9, plus 2.5, 41.5 units squared for that area. Awesome. Okay, one last problem to wrap up our perimeter and area. Terry has 19 feet of tape to mark an area in the classroom where the students may read. Oops. I'm gonna do that. Which of these shapes has a perimeter or circumference that would use most or all of the tape? A square with side length of 5 feet, a circle with radius of 3 feet, right triangle with each leg length of 6 feet, a rectangle with a length of 8 feet and a width of 3 feet. Okay, well, a square with a side length of 5, to find that area, we would just do, we're not doing area. It says perimeter, which has a perimeter. She doesn't want to know the largest area. She wants to know has a perimeter that has the most because she's marking it off with tape. Okay, I got you, Terry. So 5, so to find the perimeter of a square, we could just do 5 plus 5 plus 5 plus 5, or we know all 4 of those side lengths are 5, so we could do 4 times 5. That would use 20 feet. And she only has 19 feet of tape. That won't work. All right, let's try B. A circle with a radius of 3 feet. Okay, so I'm looking for the circumference here. If I'm looking for the distance around the outside. 2 pi r, the radius is 3. 2 times pi times 3, use pi button or 3.14. I got 18.85 feet. Okay, that could work. That wouldn't use all 19 feet of her tape. Let's look at our other options here. A right triangle with each leg 6 feet. All right, so to find my perimeter, I would have to do 6 plus 6 plus this one. All right, I'm going to give you guys that number. I did Pythagorean theorem. It's 8.49. Just to save some time here, because we know how to do that. So that perimeter was 20.49 feet. Ooh, that's not going to work. That's over my 19 feet of rope. Last option, a rectangle with a length of 8 feet and a width of 3. All right, find the perimeter rectangle. You do 8 plus 3 plus 3 plus 8, or you could just double your length, double your width, and this one is way over. You get 22 feet. That's not going to work either. So the only one that we'd be able to use that'd be under 19 feet would be B, the circle with a radius of 3 feet. Okay, that's all for lesson 1.6. As a reminder, your homework assignment would be the 1.6 worksheet and the book assignment that goes along with this lesson. Thanks for watching.